Some of the best engineers never went to college, have never taken a math class, and can't even hold a pencil. It's nature. My name is Avery, and today I'll be talking about how engineers and innovators have looked to nature for sustainable solutions. Biomimicry is the imitation of processes and designs found in nature and applying them to technology to solve the problems humans face today. Organisms have been prototyping for billions of years, evolving near optimal solutions to the physical challenges presented on Earth, such as global warming, which is the increase in temperature due to the burning of fossil fuels and release of greenhouse gases. From the homes of termites, to the fins of whales, to the very chemical processes in the ocean itself, nature has already engineered the solutions to our climate crisis. It's just up to us to unlock them. Let's travel to the savannas of Africa, where we find our first surprising engineer in termites. Termite mounds warm up during the day from the sun, but they've engineered their own natural ventilation system that regulates the temperature inside the mound. Famously, the Eastgate building in Zimbabwe has imitated the termites' design. Warm air from the day is naturally extracted through brick chimneys on the roof due to convection. Then at night, as the warm air exits, cool air flows in through low-level openings and is captured. Then during the day, the cool air is distributed throughout the building through a series of pipes and tunnels. This natural AC system uses 50% less energy than the traditional AC systems throughout the city. Next, let's look at one of the world's cleanest energy sources, wind. Turbines use wind to generate electricity, which reduces our reliance on fossil fuels. So engineers are constantly looking for ways to improve the efficiency of turbines. And surprisingly, the solution didn't come from a design lab, rather from the ocean's largest mammal. A marine biologist in the early 1980s found it counterintuitive when he noticed irregular bumps along a humpback whale's fins. Aerodynamic theories would suggest that a smooth edge would provide the best performance, as seen with airplane wings. However, after further research, the marine biologist discovered that the bumps passively modify the flow of water over the fin, decreasing drag and increasing lift. When the bumps were applied to the turbine blade, there was a noticeable decrease in drag by 33% and increase in lift by 8%, allowing for more power to be generated at lower wind speeds. Now, those two solutions address reducing our reliance on fossil fuels. But what about the greenhouse gases that already exist in our atmosphere? For that, we can turn to the natural chemical processes in the ocean. The ocean covers around 70% of the Earth and naturally absorbs 31% of the carbon dioxide in our atmosphere. The carbon dioxide is naturally extracted from the ocean as dissolved carbon dioxide undergoes a chemical reaction and forms calcium carbonate, which clams and oysters use to form their shells. And that allows the ocean to absorb more carbon dioxide, creating a cycle. But as with everything, there's a limit. Humans are producing fossil fuels at a rate much faster than the ocean can process. And so this is causing ocean acidification and making it harder for shell formation. That's where a team at UCLA called Aquatic has stepped in. They're hoping to speed up the natural chemical process by which the ocean absorbs carbon dioxide and turns it into minerals like calcium carbonate. This essentially shell dust can be either put back into the sea or sold for construction material. This is a form of long-term carbon capture storage. My research is looking at how an enzyme can catalyze the conversion of water and CO2 into bicarbonates, enhancing the uptake of this CO2 from the atmosphere into the seawater. Engineering isn't just about math and science. It requires creativity to reimagine systems and shift our perspective of how we approach problems. Some of the best ideas engineers have had have come from modifying timeless examples. We must be looking to the environment to save the environment. Thank you.
Thanks.